Welcome, ladies and gentlemen. Today we are going to talk about seismic waves. What is a wave? Wave is energy transmitted from one point to another without causing the disturbance of the medium of its transmission. And in real life, we have different applications and areas where we can observe the occurrence of seismic waves. For example, one typical example is earthquakes. Earthquakes are generated as a result of energy radiated from a point in the Earth's subsurface known as the descent that can radiate in different directions and can be transmitted to affect the life of people and animals and other creatures on the Earth's surface. And so the generation of these waves, seismic waves, for example in earthquakes, can result from interaction, for example, with different plate margins, for example the transform plate margins, divergent plate margins, and convergent plate margins. For convergent plate boundaries of margins, we have, for example, the collision of different tectonic plates. That can be maybe the collision between the Eurasian plate and the African plate can result into a generation of an earthquake. Then also the collision of another plate setting that we have is the divergent plate setting. In the divergent plate setting, we have separation of different plates that can result into generation of energy that can be transmitted in the form of earthquake. And also in other regions, for example, you can have shear forces acting between different plates, and that can also result into generation of earthquakes. It results in the transmission of what we call seismic waves. That is one example I can give you about the origin and application of seismic waves in real life. And also the other application of seismic waves, for example, can be applied in oil and gas exploration, oil and gas production, and also monitoring the entire behavior of the reservoir throughout the lifetime of an oil field. So it is very important. On the other side, meanwhile, it can be destructive for the case of earthquakes, generation of earthquakes. Seismic waves are very important in the exploration of oil and gas resources. Even can be applied, for example, in hydrogeology when you're doing exploration for underground water. Then types of seismic waves, we have basically two types of seismic waves. We have surface waves and body waves. Body waves are transmitted within the interior of the Earth's crust, while surface waves are transmitted, for example, between two media, for example, the medium between the soil and air, the lithosphere, and the atmosphere. Body waves, we have basically two types of body waves. The first one that we are going to talk about is the P waves or the primary waves. Primary waves are transmitted parallel to the direction which the wave is traveling, and the propagation of these waves depends so much on the density of the media in which they are being transmitted. The denser the media, the faster or smaller is the arrival time of the wave. And primary waves are in such a way that they travel through those solid materials. Even they can travel through fluids. When I talk of fluids, I mean air and I can say gas and liquid. So primary waves can travel through solids, and they can also travel through fluids. That is, they can travel through gas and liquid media. And primary waves, they travel fast compared to the rest of the waves and are able to reach the receiver fast compared to secondary and surface waves. So here now we're going to look at secondary waves or shear waves. Shear waves are also body waves because they are transmitted in the interior of the Earth crust. And shear waves, their propagation is such a manner that their displacement is perpendicular to the direction of the propagation of the wave. So they tend to shake the subsurface in the direction that is perpendicular to the direction which the wave is traveling. And shear waves, for them, they do not travel through fluids, they only travel through solids. That is the main difference between shear waves and primary waves. And for that, it has given shear waves a vast number of applications. Like in the subsurface, they can help us detect aquifers within the subsurface. They can also help us detect gas chimneys within the subsurface. Then they can also help us detect oil reservoirs. So shear waves are very important because they do not travel. They can produce a very clear seismic section with some anomalies that show that they do not travel inside media. So we can be able to tell or predict that we might be having oil in certain region of the crust, be having gas chimneys or water aquifer. Then with further studies, any exploratory drilling can be done, or wildcats can be drilled within the subsurface to make further confirmations whether we have such resources there. Then the last type of wave that we have is the surface waves. For the case of surface waves, then they travel very slowly and they travel in the media, as we said before, between the lithosphere and the atmosphere. And the surface waves, they are the ones which are responsible for causing earthquakes. They displace the earth in many ways. So therefore, they are the ones responsible for causing earthquakes, and because they travel slowly, they will reach the receiver late. So therefore, they are able to reach the receiver after the shear waves. So if we are to list the different types of waves that I've discussed in terms of the time by which they will be able to reach the receiver, we have seen that the primary waves, they travel fastest, and they will reach the receiver early. Then they will be followed by secondary waves. Then the last two waves to reach the receiver are the surface waves. So thank you so much for this discussion. And if you like this video, please don't forget to subscribe to this channel. Thank you so much. And if you want to receive messages from us every time we upload any video on this channel, just click the notification button. Thank you so much.